Hey guys, this installment is going to be about acid-base indicators and what's the purpose of them. So, how do we know if a solution is acidic or basic? So imagine you have a clear solution, like in a test tube, and you want to know, is this an acid or is it a base? And there is no smell to it. There's nothing that you can distinguish from the solution. Well, that's where indicators come in. If you look at your reference tables, table M has a list of indicators, and indicators usually help narrow down the pH of a solution. And you do this by using different or a combination of different indicators. There's also pH paper that's like very specific, which is pretty cool. Um, and exactly how does this work? So an indicator is a substance that changes its color. So this is how you know, oh, this is the change, the point of change. And this only happens when it gains or loses a proton or a hydrogen ion. There are several different indicators and they change differently when exposed to different pH values. On your reference table, there's a list of common acid-base indicators that show the color changes at varying pH values. Um, so we use this table to kind of help look at an unknown and be able to tell what pH that unknown is. And from that pH, you should be able to tell if that substance is going to be an acid or is going to be a base. So when we look at this table here, this is exactly what you're going to see in your reference table. And pretty much how it works is when a substance is a pH lower than 3.1, it would be a red color. When it's above a 4.4, it'd be yellow. And the in between range, so between 3.1 and 4.4, it would have like a mixture of the two colors, so it will look like an orange color. And that's how all of these work down here. So that's how this table works. This table's pretty good to use, but a much better table is what I'm going to show you on the next slide. It actually shows you colors. So this is the same thing. Um, so for methyl orange, so this little clip or snip is actually from the reference table, and it says methyl orange is red when it's below 3.1 and yellow when it's above 4.4. And as you can see, 3, anything below 3 is going to be red, anything above 4.4 is going to be yellow. So that means in between is going to be orange. Okay, and that's how all of these work here. So if you're trying to identify if something is acidic, it's good to use something like methyl orange because you know it'll turn red in something that's acidic, but as long as it's below 3. Or you could use something like thymol blue, which will turn yellow. So some of these are actually pretty good at determining if something is an acid or is a base. If you want to get more specific, that's when you start using multiple indicators, and we'll see that in the examples that I'm going to show next. Okay, so let's take a look at this one here. So the first one says, at what pH would all three indicators appear as yellow? So in the first one, it has to be below 6.2. So that means this can't be the answer. The second indicator says it would have to be at 2.8 or higher. So it can't be this one. And then the last one says it has to be higher than 4.4. So it can't be that one. So that's how we can conclude that the answer would be 4.7. Okay, so that's how you can look at a substance and determine what this unknown is going to be, or what the pH for the unknown is going to be. And based off of that, because it's lower than 7, it's going to be an acid. Let's look at this one down here. So it's giving you a set of results for 3 different indicators. For the first one, it says it's yellow, okay? And for it to be yellow, it has to be below 6.2. So that means this can't be the answer. For the next one, it's red. So it has to be below 1.2. So it can't be this one, and it can't be this one. And the last one, it says red. so it's below 3.1. So just from the process of elimination, we could already see that the answer is going to be A. So let's take a look at the next one. Next one says if the pH of a solution is 6, the solution is. So first of all, let's recall our pH scale. We know that it's from 0 to 14, but I'm just going to start with 1. And our midpoint is 7. When we have something that's exactly a pH of 7, it's neutral, so I'm going to write N. Anything in between is going to be a base, so anything between 7 and 14. Anything between 1 and 7 is going to be an acid. So we can already tell a pH of 6, which is right here, is going to be acidic. So it's either A or B. Okay? And when we look back here, anything below 8 is going to be colorless. So that means the answer, so it has to be this one right here. So the answer is going to be B, colorless. Okay, so I'll repeat it again. It is a pH of 6, so it's below 7, makes it an acidic solution. And it's colorless, so that means that it's going to be B. Let's look at this last one. So ignore this typo here. Which solution, when mixed with a drop of this indicator, will cause it to change from blue to yellow? So let's look at this indicator, which is right here. And so it's going to go from blue to yellow. So it has to turn yellow below 3.8. So let's take a look here. For it to turn below 3.8, again, if we go back to this one, anything below 7 is an acid. And they're not giving you any values here, but instead they're just giving you different substances. And so like this is an acid, this is a salt, this is an alcohol, and this is a base. Okay, so because it's below 7, that means that the pH is actually, no, it's lower than 3.8. It's lower than 3.8. So it's a pretty low number. So that means that it has to be an acid. Therefore, the answer is going to be A. Okay. If it were D, that means that our substance would have turned, or our indicator would have turned blue. But since it went from blue to yellow, that means it's going to be an acid. Okay. And my final slide here. So this was a pretty cool image that I found online. So it just shows you like when you use blueberry as an indicator. And I plan on doing this the next time we meet. So this is actually pretty interesting. It has a chemical in it that turns or gives off different colors at different pHs. But when it interacts with a base, it starts to get darker and darker. Hence why it went from green to like really, really dark purple. So it's pretty interesting. And I hope that this was interesting enough for you guys and that it was very clear. And if you have any questions, just reach out to me.